Hello guys, welcome to another video. I'd like to start off today's video by, first off I'll do the summary of the most important thing we learned about the last lecture. I'll take like 7 minutes, I don't know how long it takes me to talk. After which I'll do some examples, 2-3 examples, and I'll summarize everything we've done so far. So the most important things we learned in the last video was from this idea. Everything was generated from this idea was equal to tan A minus tan B divided by 1 plus tan A. Okay, so if we had one line, another line, L2, L1, angle between them was phi, angle here was beta, angle here was alpha. Then we said that beta minus alpha logically is equal to phi. Therefore, tan of beta minus alpha is equal to tan of alpha. But before my previous video, the last 2 videos, I wrote a statement, an important statement, that tan of theta is equal to the slope. And I showed how tan phi could be a slope if L1, well, L1 is an infinite line that goes off to infinity, was a rotated coordinate system, and we learned a transformation law for a special coordinate system that was rotated by an angle theta. And I showed how theta can be an angle, and can be a slope of L2 if L1 was one of the axes. So tan of beta is equal to the slope of L2, and tan of alpha is equal to the slope of M1. However, tan beta minus alpha is equal to tan, I'm not too sure if the camera extends up to there, so I'm going to write it lower. Tan of beta minus alpha is equal to tan beta minus tan alpha divided by 1 plus tan alpha tan beta. We've already defined what tan alpha tan beta is, so tan of phi is equal to m2 minus m1 divided by 1 plus m1 m2. If the angle between M1, if the angle between L1 and L2 was the phi is equal to pi over 2, tan pi over 2 is equal to infinite. So if that was infinity, and we defined infinity to be 1 divided by 0, this is not really a good definition, but we can't divide anything by 0, so we just say it's undefined or infinity. So let's put that here. So 1 divided by 0 is equal to m2 minus m1. In which case, if you cross multiply, you have that m2 wait, give me a second. I made a mistake. Tan of pi. So tan of pi over 2 is equal to sine pi over 2 divided by, oh no, there's no mistake. There is no mistake. So if I go on, cross multiply, this part becomes 0. So I have 1 plus m1, m2 is equal to 1, m1, m2 is equal to -1, m1 is equal to negative 1 divided by m2. So we can deduce that if the angle between two lines is 90 degrees, or if two lines are orthogonal or perpendicular to themselves, then the slope of one line is the negative reciprocal or the negative inverse of the other one. It works the same way. If you solve for m2, to the negative inverse of m1. And then we can also do some proofs for parallelism of lines. So I've showed perpendicularity of two lines. So if the angle between two lines is 90 degrees, or more preferably, we normally use pi over 2, then the relationship between the slopes is that the slope of one line will be the negative inverse of the other one. And if phi is equal to 0, then tan of 0 will be sine 0 divided by cos 0. That's equal to 0. So we have 0 divided by 1 is equal to m1 minus m2 divided by cross multiply. This term becomes 0, so you have 1 equal to m1. Oh, sorry, give me a second. So you have, so you cross multiply. So you have this, so 1 plus 0 times that is equal to 0 is equal to m1 minus m2. So m2 is equal to m1. So if you have two lines in which the angle between them is 0 or 180 degrees, so if I have 0 or pi, then the two vectors, I'll start using the words interchangeably now, so lines and vectors. The two vectors of the two lines will be scalar, have the same slopes. In vector, we say they are scalar multiples of each other. So m1 equal m2. Now we're going to use this idea to do some 2-3 examples, I guess. I don't know how much it is. And we're going to try to do it very quickly so we can finish off today's work. First example is as follows. If two lines, L1 is perpendicular to L2, and the slope of L2 is and the equation of the line of L2 is equal to, let's say, 2x plus y equal 4. Well, let me write it more explicitly. This is called the general form of the equation of a line. 2x plus y minus 4 equals 0. That's the equation of line of L2. Find m1. Right, so we know something. If these two lines are perpendicular, therefore the angle between L1 and L2 is 90 degrees. In which case the slope of L2 will be the negative inverse of the other. So if we rewrite this and we solve for y, we want to write it in form y equal x plus c. I'll derive this later. We have that y is equal to minus 2x plus 4. M is equal to -2, C is equal to 4. M2 is equal to negative inverse of M1. And if we know what M2 is, negative 2 is equal to negative 1 divided by M2. negative 2m1 is equal to negative 1, in which case m1 is equal to half. That'll be the slope of L2. So these doesn't get any, it's quite easy. No, I think I'll leave it on the board. And the other question is as follows. If these points, okay, if one-third P let's say negative one-third of P and half of P minus 1 are points find P. Okay, so we know two things. We know first that x1 is equal to negative one-third, P is equal, y1 is equal to P, x2 is equal to half, y2 is equal to P minus 1. We know one thing for sure. Let's make it more. Yeah, P minus 1. We know one thing for sure, that y2 minus y1 divided by x2 minus x1 is equal to a point in L1 is equal to m1. y2 minus y1, I hate this. Let's make it 2. Let's make it 4/3. y2 minus y1 is equal to 4/3 b minus 1 minus p delta y is equal to P. So we have delta y. I'm going to do a very step by step here. P minus 4 divided by 3. You know what? Let's even make P more to be more composite, I guess. Let's say it's P minus, let's say it's 3p minus 2. Yeah. 3p minus 2. So we have, now we have to be very careful. The minus goes in, now be minus 3p minus 4/3 plus 2. Right, so 4/3 of p minus 3p 1/1, 3, 4 minus 4p minus 9p. Okay, so we have equal to minus 5 divided by 3p. So we have that delta y is equal to, and let's do, that'll be minus 5 divided by 3p, and say 2 minus 4/3, 3, 6 minus 4. So that'll be 2 plus 2, 2/3. So that'll be delta y. That's delta y. Delta x is equal to half minus a third. Half minus a third, that'll be 3, that'll be that'll be 6, that'll be 3, that'll be 2. So we have, that'll be 1/6, right? So yeah, that'll be 1/6. That'll be 1 divided by 6. So you have that delta y divided by delta x is equal to minus 5/3 of p plus 2/3 divided by 1/6. And this is equal to m1, right? So we have, if you turn this to a multiplication, we have that delta y divided by delta x is equal to minus 10p plus 4, right? So yeah, plus 4, and this is equal to m1. So you have minus 10p plus 4 equal to m1. m1 is a half. So minus 10p is equal to a half minus 4. That'll be minus 3.5, but yeah, so that'll be minus 7 divided by 2, but let me just do it more explicitly. So 1/2 minus 4 divided by 1, 2, 1 minus 8, that's minus 7 divided by 2. So we have 10p is equal to minus 7 divided by 2. Hence, p is equal to minus 7 divided by 20. That's the value of p. So I just had to make, because if I had left this as p and say p minus 1, then we'll be done somewhere here. But I wanted to make it more, there was more algebra involved. So yeah, that's the point. And the last question. Given that px minus 4y is equal to 7x plus 5. 7x plus 5. Given that to be the case, given that line, let's call it line L0. If L0 is perpendicular to L1, or let's call it L, I'll be back. Yeah, let there be light. So if line L0 is perpendicular to L prime, where L prime is equal to 2x plus y minus 1 equals 0. 2x plus y minus 1 equals 0. So that's the equation of L1. Of L prime, sorry. Find the value of p. Okay. Now you have to think about it a little bit. So line L0, L sub 0 is perpendicular to L prime. You know what that means. The angle between both of them is 90 degrees, or pi over 2. So let's write L prime in a more general form. So I know 2x plus y is equal to 1, in which case y is equal to minus 2x plus 1. We know something for sure, that m prime, slope of L1, of L prime is equal to minus 1 divided by slope of m0. Right, so we know that's the case. We don't know what m0 is, but we can deduce. We can find what m0 is. So m1 is -2, therefore m0 will be a half. We did something like this before. Okay. Now, let's write L0 in a more general form. We're trying to solve for y in this case. So write it in the form of y equal mx plus c. So minus 4y is equal to 7x minus p, right? I hope you get this. 7x minus p plus 5. Hence, y is equal to negative, you know what, let's write out 7 minus p, no, sorry, minus 7 minus p x divided by 4 plus minus 5 divided by 4. So that's the equation of L sub 0 or L naught. So I already know what this is going to be. So you want to write the analog, that is y equal to mx plus c. M is equal to negative 7 minus p divided by 4. C is equal to negative 5 divided by 4. Or you can easily solve. Well, you just do the algebra. So you have p minus 7 divided by 4 is equal to 1/2. Then you can solve for p. To solve for p, that's 2p minus 14 is equal to 4. 2p is equal to 18. P is equal to 9. And we can cross check that. So if we put p equal to 9, m is equal to minus 7 minus 9 divided by 4. Right, so that'll be minus 2, that's 2 divided by 4, it simplifies to 1 divided by 2. So we've already cross-checked that, that's correct. So yeah, that's all for examples. So let's go into today's main work. So today I'll try to complete at least equations of a line. What else? Yeah, so 2 things today. We're gonna first discuss collinear points and then forms of writing the equation of a line. Okay, so collinear points. Now, once you hear the word co-something, collinear, co-anything, what comes to your mind, at least I know what comes to my mind, is that I think of similarities, excuse me. So you start thinking of things that are, common to both things. So when I say collinear points, it means that is like points that are on the same line, just like straight to the point. So yeah, so collinearity of points. If we have a line in a two-dimensional space, and we say that this point and I tell you that these 2 points, okay, so I tell you these 2 points are collinear. What they simply tell you is that they lie on the same line. So it tells you that the slope between this must be the slope of the line. Between these 2 points must be the slope of the line. So any 2 points you can find on a line will give you the slope of the line, or the direction of the line. We'll talk about that later. So yeah, that's really what collinear points mean. So I'm going to have to form some points that are, you know, collinear. So let's take I'm actually gonna make it simple. So if I have this 1, 1, it's not actually the case, but let's draw it like this to make it more simple. So I have 1, 1, 2, 2, 3, 3, and so on and so forth. And I label them A, B, C, D. I don't want to use this picture. Let me use a more abstract picture, because that's too easy. Let me think of something more at this point. Note that these points could form vectors. Yeah, note that these points could all form vectors where the terminal point of the vectors terminate at the points that you're describing. So if I'm trying to describe A, I could more or less call it a vector originating from the origin of some axes, or yeah, where the terminal point is at the first point, for B terminal point is at the second point, and so on and so forth. I want to make, because I want to relate those two vectors a little bit. So if I have 2 points here, so let's call this point 4. I want to use even numbers because even numbers are easy to work with. 4, 6. No. You know, let's call it. Yeah, so let's call it 4, 12, right? And let's call this point 3, 6. Now, from these 2 things, we can actually determine what the slope of the line is. The slope of the line is delta y divided by delta x. Right? So delta y is 6, delta x is 1. So the slope of the line, or you know what we could do? Let's talk about it in terms of vectors. So the vector CD will be delta xi plus delta y j, right? So CD is equal to delta x. What's delta x? That's I plus plus 6j. Now, this is the point I'm trying to make, okay? That the vector CD must be a scalar multiple. Let's call the scalar multiple K. Do we use K? Let's call it lambda times the vector BC. It's more or less when you have velocity and speed. There's a difference. The difference is velocity is obviously a vector and speed is a scalar. While the direction in velocity is what actually gives the velocity, it's velocityness. That's not a word. But like you have it like V times V. This is the definition of velocity. So it's the magnitude of the velocity, which is the speed, times the unit vector of the velocity, which gives it the direction. So CD must be a scalar multiple of BC. Let the point BC be, the most important thing is that the slope must be the same. So let the line BC be, let's say, let say 6 minus, so you have 3. Yeah, so, and let this be a half, right? So, what's the vector BC? The vector BC is, what's it called? So, delta x I plus delta y j, so BC is equal to delta x. What's delta x? Delta x is 3 minus a half, that's 2.5. That's 5 divided by 2. That'll be 5 halves of I plus 3j. Right? So the vectors might not look the same, but if you kind of analyze it, you see that they're actually scalar multiples. And I'll give you some interesting facts about collinear points. So, because I'm trying to bring out all these points from my head. So the thing is, if you multiply through by 2, so 2 times BC, that's a scalar, times BC is equal to 5I plus, it's not the same thing though. 6j, it's not the same thing, is it? Oof. Give me a second. So, what's the slope? The slope was 6, yeah. So I have 6 minus 3, that's 3. Oh, I made a mistake. Give me a second. I have to fix this properly. So that's the general formula for BC. So plus delta yj. So it must be that. I made a mistake. So 3. Yeah, so x is actually not half. X has to be 21 divided by 6. So to prove this, okay, so normally, this is just by the way, so normally delta y divided by delta x is equal to 6, right? So that's the slope. So if I do for B and C and B, so 3 minus 6 minus 3, that's equal to 3 divided by 3 minus 21 divided by 6. So if I do 23 minus, that's 3 divided by 1 minus 21 divided by 6, that's 6 minus 21, that's 18. And 18 minus 21, that's negative 3. What am I doing? So 3 divided by 6. Okay, so this is the thing. The answer